So I just wanted to show a few things here. So basically, I'm not going to like walk through this. We're just the notebook is here. It's under advanced sampling, and then the solutions are there too. And I'm totally cool if you just like if there's something you're not stoked about doing, just you can look at the solutions. That all seems fine to me. There's so much in here, so I want this to be a useful resource. But a few things I wanted to show were just some of the useful documentation. So this is the documentation page for MC. It's mc.readthedocs.io. But we're not using this version of it. We're actually using a pre-release version. So you want to go down to the bottom corner and click to latest instead of stable. And it should look like this. And it has all these red errors and stuff. It's bad news. But anyways. And this is the current version of the documentation that we'll be using for today. And then Dynasty has a similar page that looks similar. And it has all of the relevant docs for getting started with Dynasty. And then PyMC3 also has a documentation page that looks like this. So those will all be useful references. And then I just wanted to very quickly give you a summary of what's going on in this notebook. So there are two examples, and there's a part 2 to the example number 1 that's like super challenge, and then problem 2 is also very challenging. And so I don't think I could finish this in an hour and a half, and I know all the answers. So like Adam said at the beginning, this is meant to be just something like a useful resource. So the first example, like every other tutorial, is fitting a line to data. But the catch here is that we're going to do it in MC Dynasty and PyMC3. And the way it works is I have, so a lot of the code exists already, but that one is, oops, let's see, here we go. That one was the solutions, but in the non-solution version, I have these functions defined right here with your code goes here, and you're going to write the code that is explained above inside of that function, and then below it, there's a unit test. And when you correctly implement everything, it will say that it passed, and it'll give you a smiley face, and then you know that it's safe to continue. I've hopefully covered most of the relevant corner cases. And so I go through this, work with your partner, look at the docs, give me a shout. There are other people in the room who have used some of these packages before. And yeah, we'll sort of get as far as we can, and hopefully this will give you some intuition for how the packages are connected. Don't forget that there's coffee and water and stuff outside if you need to get a drink. I know that I'm parched. Any questions at this point? Good. Okay, well, as you're getting started, I just wanted to show, I don't know how to take videos from Twitter, so I wanted to show this tweet, which is a visualization of Hamiltonian Monte Carlo, because I thought it was pretty cute, and I'll let you look at that as much or as little as you want. All right, everyone. So I think it's now time to start wrapping up on the problem set, because it's coffee o'clock. How's everyone's brain doing? We still have a few more days of this, so a few things. So does anyone have any questions right now that would be useful for everyone to chat about? If there are individual questions, I'm happy to continue chatting over the break or later in the week. Anyways, I'm just going to show a few of the highlights of the solutions. Okay, let's just zoom out a little bit to make this a little bit less hideous. Just because I think people really did a lot. I was very impressed. Uh, but there were a few sort of specific things that I wanted to point out as sort of learning moments throughout this. And so the first one is, so the first problem was, a relatively simple one, and really the goal that I wanted to show was that, basically all three methods give exactly the same answer in exactly the same amount of time. Maybe some required a little bit more like Conda version installing and others, but so that was kind of the idea there. And so did anyone get a chance to, I'm going to actually pull up, yeah, these are the solutions that I ran on my computer. So the challenge problem was one that this one is sort of, I like this example because it's a place where PyMC3 really rocks. And so if you did this, basically the idea with this problem was that we now have error bars on our x coordinates, and you want to take those into account. And the one way of taking those into account is to add n new parameters to the model. So you'll remember that Adam was talking about how it is possible to fit more parameters than data points. Here we would have number of data points plus 3 parameters, and we're going to fit for all of those. And so if you had a chance to get this, you might have seen, or I'll just assert now, that you can implement it in MC, and it runs for much longer, like orders of magnitude longer than the previous example, and got many fewer effective samples than in the previous example. So that was what I was talking about, where having more parameters gets bad for MC. Running it with Dynasty, actually, I found took a very long time. It was really painful, and part of that is that the prior volume is very large as you add more parameters. So it also suffered seriously going to this. But when you implement it in PyMC3, it takes exactly the same amount of time and gets exactly the same number of independent samples as the previous version, which is because it's designed to work with these types of problems with lots of parameters. So this is exactly the kind of thing it was designed for. So it'd be worth going through and taking a look at these solutions if you didn't get a chance to work on them today. And so then, I don't know if anyone had a chance to look at example number 2. It was a lot, I know. But the idea with example number 2 was to do something a little bit more realistic. We were fitting simulated radial velocity exoplanets using these methods. And I didn't ask you to implement, sort of even just implementing this problem in one of the samplers would take a bit of work if you're not familiar with them. But in the solutions, I actually went through and implemented it in all 3. And so it would be worth looking at these things. And one of the things, so many things. Okay, so one of the things that I wanted, the sort of learning moment in this example is that we have 2 planets, and they have different periods and different semi-amplitudes. And you can sort of see that there's this beating going on in here. And the key realization is that if you call one of those planets planet B and one of them planet C, then that's exactly the same model as swapping the 2 labels and changing the period. There's a perfect degeneracy in this problem. And this is a place where Dynasty really shines. So if you run this model with Dynasty, these are what your posteriors look like, which sometimes would be scary, but in this particular case, it's exactly right. So you see that there are these 2 modes. So if these are the 2 periods, period 1 and period 2, and you can see that it's fitting both of them, but it's also fitting for the label swapping degeneracy. So it's able to find both of those modes without any trouble. And so that's sort of the thing to learn here, is that, you know, if you have some situation that looks like that, then something like nested sampling can be very useful. Now, in order to deal with that problem, so PyMC3 is not very good at handling label swapping degeneracies like that. And so the way that I dealt with it, it was to force the results to be ordered by period. So period 1 always has to be less than period 2. And so that breaks that degeneracy. And then PyMC3 does a great job and has no trouble sampling it very quickly. But it's sampling a different problem than Dynasty was. And there's some question about, you know, which is right or which is more useful, or, you know, there's sort of some interesting discussion to have around that. But we're not going to have that right now. We can discuss it later if you're interested. And so those are all the things that I wanted to talk about. I'm hoping that this notebook is a useful resource for trying out these different methods in your work. Yeah, any questions at this point? All right, let's call it coffee. No, you want to make an announcement, Adam? All right.
First, let's thank Dan one more time.